Right, chapter 10 is about gases. Now, liquids and solids actually have similar characteristics. Gases are like totally different, so they get their own chapter. Um, Characteristics of gases, what's kind of crazy about them is it doesn't matter what type of gas you have, if it's oxygen gas or nitrogen gas or hydrogen gas, their physical properties are very similar. In other words, they look the same, they act the same in well, their melting points, boiling points, and things like that. They're very similar to each other. It doesn't matter what the gases are. Okay, your gases are going to be composed of non-metallic elements. We're talking the non-metals like, excuse me, oxygen, nitrogen, hydrogen, fluorine, chlorine, bromine, those guys. Okay. Unlike liquids and solids, the gases will expand to fill their container. Okay, so if you have a gas in a 2-liter bottle, it'll fill that 2-liter bottle. If you let it loose and put it in a room that's 250 liters, it will fill the 250 liters. It will spread out as far as it can. Okay, it's very compressible, so you can squish gases back down. Okay, and they have very, very low densities. Okay, remember, water is 1, liquid water is 1. All the gases are like 0.2, they're very, and remember, density is how close are the particles. Well, in a gas, they're really far apart. And you can take 2 or more gases and mix them together and form a homogeneous mixture, a solution, like air. Air is nitrogen gas, oxygen gas, water vapor, carbon dioxide, some of the noble gases. There's all kinds in there, and they're all mixed together, and they're well mixed because you wouldn't want to see layers in your air. Okay, here's some common gases. Again, hydrogen cyanide. You guys don't want to stay if you ever smell almonds, get out of there, because if you breathe it in, you'll die. But anyway, sulfide, hydrogen sulfide, carbon monoxide, carbon dioxide. These are all, and you'll see they have pretty low, like the heaviest one is probably SO2, sulfur dioxide. What would that be? 3296. So they're all under at least 100 grams. They don't weigh a lot. Okay. Some of the things, there's the things about gases is there's properties that can change them. Okay. There's 4 things that you can look at when you're talking about a gas sample. One of them is temperature. When you increase the temperature, you increase their volume. Okay. Pressure. Okay. If you want to change the volume of a gas, you can increase the pressure or you can decrease the pressure. Another one is volume. Okay. The volume, again, if it's in a small container, it'll be whatever that volume is. If you open it up and let it expand, it'll take up more volume. Okay. So pressure and temperature affect volume. Volume and pressure affects the other 2 as well. And the last one is the amount of gas. How much gas do you actually have? And it's usually expressed in the number of moles. Okay, that's kind of the way we measure things in chemistry. So the number of moles. Okay, so we've discussed, these, and I'm going to show you laws that pertain to either 2 of these or all of them. It depends on what you're looking at. Okay, so there's probably 20 gas laws. I think we'll do about 5 or 6 of them. But there's a lot of gas laws, and again, you can determine things about gases using these laws. Okay, one of the things about pressure is force in an area. Okay, atmospheric pressure is the weight of the air, and most of the atmosphere, the closer you get to the ground, the higher the atmospheric pressure, because it's pressure is amount of force in applied area. Okay, so when you're talking about atmospheric pressure, they have a 1 meter by 1 meter area. Okay, and then how much force is there? And again, as you move up, like when you're in Denver, you don't have as much atmospheric pressure as you do when you're in Belcourt, because Belcourt is lower than, so the lower you get, the more pressure you have. Okay, because of gravity, plain and simple. Okay, there's many units of pressure. It'd be kind of nice if they stuck with one, but one of them is called a Pascal. It's this metric system unit. It's a Newton meter squared. Here is the old barometric pressure, if you have a barometer or whatever, and it's measured in millimeters of mercury. Okay, the way it works is there's pressure out here, there's mercury here, and there's pressure applied, and it forces mercury up here. So then you read here. This is where you actually get your number of reading. And if you're talking about at sea level, this would be 760 millimeters of mercury. They don't use these too much anymore because kids like me back in my day, we used to break these things open and play with the mercury until they decided mercury really wasn't that good for us. So people of my generation and older, the reason why we're a little bit wacky, we probably spent too much time playing with mercury. Anyway, so when you look at units of pressure, there's 1 Pascal. There's also a bar, which is 100 kilopascals. It's a unit. Okay, a millimeter of mercury or torr, those two equal each other. So if I was at sea level, it would be 760 millimeters of mercury or 760 torr. Okay, and again, this is how it's read with the mercury. If you want to do conversions, okay, 1 atmosphere is 760 torr, which is also 760 millimeters of mercury, which is also 101.325 kilopascals, which is also 1.1, I just used 1.1 bars. So if you know one, you can convert to the other easily. Usually when you're doing problems, they give you it all in atmospheres or all in torrs or all in kilo, but you can easily convert, okay, by, like we did our other ones before. If I want to change millimeters of mercury to atmosphere, I'd start with whatever I have millimeters of mercury. I know that 1 atmosphere is 760. I would divide and then I'd have my answer. So you can easily convert from one unit of pressure to the other. Okay. They have something called a manometer. Sorry, you guys. Manometer is used to measure the difference in pressure between atmosphere and in a gas. Okay. And the atmosphere and the height would give you the pressure in the gas. Again, the barometer was on the last slide. This is another way of measuring pressure. And again, they're just using the differences in, you can see here's the pressure released by the gas, the difference in the height. And then you've got the tube is open so that the atmosphere can put pressure on it. So the difference between the two would be your, when you add the two together, you would get the pressure of your gas. Okay. So standard pressure. Okay. If we're talking standard pressure, we're at sea level. Okay. Standard atmospheric pressure is 1 atmosphere or 760 millimeters of mercury or 760 torr or 101 kilopascals. That's all standard atmospheric pressure, and that's at sea level. Okay. So, I guess I said all those, sorry. These all equal each other. Usually you'll see it as an atmosphere. Okay. But these can be, these all equal each other. And that's what happens at sea level. In Valcourt, we're not at sea level. We're a little bit higher than this. Okay. Okay, so Boyle's law is the first one we're going to talk about. Where am I at? Oh, good timing. The volume of a fixed quantity of gas. Okay, so we're not changing the amount of gas and we're not changing the temperature. All we're looking at is pressure and volume. And I always remember Boyle's law is the pressure one because BP would be blood pressure. Yeah, I know. I have to come up with these weird things to remember things because I'm old and I have to do that for my little brain. Anyway, Boyle's law says that the pressure is inversely proportional to the volume. And if you look here in a balloon, okay, if you have a balloon and you squish it, you apply more pressure to it, the volume gets smaller. If you let off that pressure, the volume gets larger. So they're inversely, when you increase one, you decrease the other. Okay, here is, you can see it mathematically. PV is a constant, so the pressure volume. So when you're trying to figure out if you have the pressure and volume of a gas and you change either the pressure or the volume, you can figure out the unknown one, the one you don't know, very simply by multiplying these two together and dividing by the one you know, and that'll give you the one you don't know. Okay, here's graphs of it. But again, remember that Boyle's law is inverse. And in other words, if you increase one, you decrease the other. So when you're looking at these, if I increase my pressure, my volume's going to go down. So that's one way you can look and see if you messed up. And here's, if it was directly, it would look like this, but it's not. It's inversely. Inversely means when you increase one, you decrease the other. So here I have my volume at 1, and here's my pressure at 1. If I decrease or increase the pressure, I'm going to decrease the volume. Okay. So again, that's an inverse relationship. Okay, so if you have 5.6 liters of gas in a piston at a pressure of 1.5 atmospheres, so we've got volume and pressure of 1. and we compress the gas, now we're going to change our volume, okay, from 5.6 to 4.3. What will be the new pressure? Okay, so what you do is you just multiply by those two and divide by that one. Okay, there's my formula. So if I take 1.5 times 5.6, and I'm looking for the new pressure, and this is the new volume I know, basically I'm going to bring it over here. So 1.75. Okay, so if you look, I have this at this atmospheres, and I'm going to decrease my pressure or my volume. I'm going to have to increase my pressure, which I did. I went from 1.5 to 1.75. The only way I can make the volume smaller is to increase the pressure. Okay, so Boyle's law is pretty simple. You take the two that you know and you divide by this, and that'll give you a new one. Again, here's the formula. Plug in the numbers. It's Boyle's law is probably one of the simplest gas laws. Okay, another one is Charles' law. Charles' law deals with volume and temperature. Okay, and when you deal with gases, it's absolute temperature, you guys. In other words, you have to use the Kelvin scale. You have to take the Celsius temperature and change it to Kelvin, which is really simple. You just add 273 to it. Okay, with Charles' law says that the pressure is directly proportional to the temperature. And again, think of a balloon. You ever gone by one of those Mylar balloons in the winter time and they pump it up for you and you take it outside and it gets small, it squishes up, and then you bring it in the house and poof, it pumps back up again. Okay, so when it's outside and it's cooler, it gets smaller. So as you cool it down, its volume also decreases. But when you increase its temperature, its volume increases. So this is a direct proportion. When you increase one, you increase the other. Decrease one, decrease the other. So Charles' law deals with temperature and volume. Okay, and again, it's a direct one. So when you increase the temperature, you increase the volume. Okay, so if you're looking at a formula, the volume of 1 divided by the temperature 1 equals the volume 2 divided by the temperature 2. And again, you just use this formula, manipulate it till you find what you need to know. Okay, and again, the graph would be linear because it's a direct. So remember when we did Boyle's, it was down this way. That was inverse. This one's direct, so when you increase one, you increase the other. Okay, so calculate the decrease in temperature when 6 liters at 20 degrees Celsius is compressed to 4 liters. Okay, now here's our formula. V1 T1 equals V2 T2. What do we have here? We have the volume and the temp. And again, I'm going to change this temperature to Kelvin. So it's not going to be 20, it's going to be 293 because you have to add 273 to any temperature. Okay, and then I got this volume. I'm looking for T, 2. So if I manipulate my formula, if I take the second volume times the first temperature, divide by the first volume, I will get my answer. And again, it's just using simple manipulation of formulas. Okay, and again, like I said, you have to change your temperatures from Celsius to Kelvin, which is really easy. You just add 273. So 20 degrees Celsius is 293 Kelvin. Okay, so what I'm going to do, plug in my numbers. Okay, my volume, my second volume is 4 liters. My first temperature was 293. My first volume was 6 liters. So I'm going to take 4 times 293, divide by 6, and I get 195.3 Kelvin. Which, if you look at this, makes sense because if I'm going to decrease my volume, I need to decrease my temperature. Okay, this was 293. I lowered it almost 100 degrees to change my volume from 6 to 4. Okay, so that's Charles' law. Okay, so Boyle's law deals with pressure and volume, and again, BP, Boyle's law, blood pressure. Okay, and Charles deals with temperature and volume. Okay, I'm going to quit here because I'm like at almost 15 minutes, and then we're going to do some of these problems, and then we'll come back and I'll show you some more. Okay.